A low unit price can become an expensive manufacturing decision when the part cannot be cleaned, finished, inspected, or accepted without additional work. For low-volume complex metal components, choosing between selective laser melting and CNC machining is therefore a system decision. The real objective is a verified functional part delivered with acceptable geometry, material behavior, finishing effort, schedule, and risk. Start with what the component must do. Define its loads, thermal conditions, corrosion exposure, pressure boundaries, fluid paths, interfaces, fits, service requirements, and failure consequences. Then identify which features create measurable value. Complexity alone is not a reason to select SLM. SLM becomes compelling when design freedom changes performance or removes manufacturing operations. Internal channels can follow paths that conventional drilling cannot reach. Lattice structures and organic load paths can reduce mass while retaining required stiffness. Part consolidation can replace multiple components, eliminating fasteners, seals, welds, alignment work, inventory lines, and assembly inspection. But every additive feature must remain manufacturable and verifiable. Internal passages need a practical path for powder removal. Supports must be accessible. Surface condition must suit the intended flow or heat transfer duty. Blind cavities, narrow passages, abrupt turns, and inaccessible voids require early scrutiny. A channel that works in CAD but cannot be cleaned, inspected, or functionally tested is not ready for production. Build orientation also affects more than machine time. It influences support placement, rough surfaces, thermal stress, powder evacuation, and subsequent machining access. These effects depend on the alloy, machine, feature size, build strategy, and supplier controls, so generic design limits cannot replace a part-specific review. CNC remains the lower-risk route when geometry is straightforward, cutting tools have direct access, or critical finishes extend across multiple external faces. It is also strong when the design depends on a known wrought material condition, established machining allowances, familiar surface behavior, or repeat quantities that spread programming, setup, tooling, and work holding across more units. Cost comparisons must include the complete route from released CAD to accepted component. CNC costs can include stock, programming, fixtures, tooling, cycle time, and secondary operations. SLM costs can include orientation work, supports, machine time, depowdering, heat treatment, support removal, machining, finishing, and inspection. Both routes also carry design iteration costs, scrap exposure, inspection development, and the schedule impact of resolving nonconformance. For factors make these trade-offs visible: geometry and function, batch economics, performance and material, and finishing and verification. Geometry may bring SLM into consideration, but finishing and acceptance requirements often determine whether it stays there. Low volume itself is not a fixed quantity. A prototype, a validation lot, a service spare, and a recurring small batch can require very different levels of process control and approval. The choice does not have to remain binary. A hybrid route can preserve printed internal geometry while machining datum surfaces, threads, sealing faces, mounting interfaces, and critical fits. Likewise, an additive sample may be best for testing a new flow path, while CNC becomes preferable after the geometry stabilizes. Process selection can change as evidence improves. Before release, bring design, manufacturing, quality, and procurement into the same review. Record assumptions about material, orientation, supports, machining, finishing, inspection, and acceptance. Use a functional sample to test the claim that justified the selected route, whether that claim involves thermal behavior, flow, stiffness, fit, lower mass, or assembly reduction. The defensible choice is the route that converts valuable geometry into verified performance. SLM, CNC, and hybrid production are complementary options. Each succeeds when its full manufacturing and verification burden matches the component's actual requirements.